All right, so welcome to our first class in Algebra 1. Just want to go over a few things. These PowerPoints are available in English and Spanish on the website. Also, if you need a different language, please let me know and I can start trying to work those in as well. Remember that 25% of your grade is from your classwork every day. So as we're doing small group work, as we're doing independent work, as I'm moving around the room to see if you have any questions or we're working problems together in class. As long as you are participating, doing the work, making the attempt, asking questions, you're going to get all your points. If you want to sit on your cell phone and ignore me and do something else, then you won't receive your points. All right. Another 25% of your grade will come from the weekly quizzes. Those quizzes will be online through Edulastic. Again, from the website for that day, the link will be provided on quiz day, and you'll be able to go in and take it. It shouldn't take too long. They're only about 10 points each, but they will summarize everything we've worked on that week, check in, see what you understand, what you don't, and we'll use the rest of that quiz day to review. You can ask questions about things you didn't understand once you saw them on the quiz. And that way we can get these questions clarified before you take your mid-unit or end-of-unit assessments. And then the other half of your grade will come from the mid-unit and end-of-unit assessments, and those will be through the KIDM website. We'll also be using the KIDM website on a daily basis for your cool-down tickets. So as we're going through the PowerPoints each class, if you want to do the warm-ups and the activities on KIDM, that's perfectly fine. You can do them at your desk on a piece of paper or up on the whiteboards that I'll have around the classroom. But when it comes to the cool down at the end, you will need to do the cool down through KIDM, and your mid-unit and end-of-unit assessments will be on KIDM. These videos that go with the PowerPoints are to help you out. If you have to miss class, you're sick, something comes up at home and you can't come in, you'll still be able to go to the class website, pull up what we did that day, and there you'll have access to the PowerPoint as well as this video where I explain the material, the activities that we do. There will also be a permanent Google Meet link. I will activate that during class each day. You won't see the class. My computer camera will be facing the closet behind my desk. But if you're at home, you can log on. It doesn't matter whether it's your class period or another class period in the day. You could log on to that Google Meet link, which I will post only in my classroom. Let me know you're there. And if you have questions or you need anything clarified, I will find time to get on there and answer your questions for you. So even if you have to miss class, you still have access to the material we went over that day so that you don't fall behind. Okay? This class is meant to be interactive. It is meant for you to work with your classmates to discover these mathematical concepts, because math is just the language that we use to make sense of what is going on around us. It's the patterns we recognize, the calculations we use to make predictions about what will happen in the future based on what's happened in the past. And that is what we really want to dive into. We want to dive into the critical thinking and the problem solving aspects. Okay. Google can tell you a formula if you forget it. Your calculator can tell you the answer to multiplication or division. ChatGPT, which I will allow us to use in this class, can help you understand how to do these processes if you don't understand from class. Okay, you can ask it, how do I create a dot plot? And it will give you instructions on how to do that. All right, what those resources can't do is critically think for you. That is something you're going to have to develop in this class. The ability to look at what is in front of you. How do I go from the information that has been given to me to the information they want me to find? So that's what we're going to work on in this class. And the very first lesson here is about data representations. We're going to look at dot plots, histograms, and box plots. We're going to look at how to take number sets and create these visual displays, because towards the end of the unit, what they expect you to be able to do is take a word problem or take a data set and create these visual displays, as well as take these visual displays, pull the information out of them, and be able to answer questions about those visual displays in context. So we're going to start off in the beginning of the lesson simply understanding how to take numbers and turn them into the displays. And by the end of the unit, we want to be able to understand that in context of what we're talking about in any given problem set. All right, we're going to be able to take one box plot and understand what the median is, or understand what the variability is. Or we're going to be able to take multiple box plots or dot plots, and we're going to be able to compare and understand which one has a higher average or a lower average, or which one has more variety, which one has less variety. That's what we're going to work up to. So as we look at the PowerPoint here, this lesson, the goal is to represent and analyze data using dot plots, histograms, and box plots. Now, these are visual displays that you should have learned about in junior high math, all right, middle school. For example, the picture here in the middle of the slide is a histogram. So we're going to look at, how do I take this histogram, the labels, the numbers on the axes, the bars going up, and how do we pull the data out of it? What does this represent? That's what we're going to take a look at. So on this slide, we have our learning targets. These are the statements that at the end of the class, you want to be able to say, you can do these things. If you look back at these at the end of the class and you cannot say these things, then those are the types of questions you need to bring up to me during class, the next class, send me an email, use our website. There is a forum on the website where you can ask about the class or about the school or about the unit that we're on. You can go in and answer other people's questions if you know the answer, and I will also be checking those forums so that I can provide answers as well. So in this lesson, we have, I can find the 5-number summary for data. We are going to go over how I take a data set of numbers and I find the 5-number summary. So at the end of this lesson, if you still don't understand what the 5-number summary is, or if you understand how to find some parts of it but not the others, then those are the types of questions you need to ask me so that I can clarify those for you. And then our other learning target is, I can use a dot plot, a histogram, or a box plot to represent data. Okay, you need to understand how to use all 3 of those. And by use, that means you need to understand how to create all 3 of those visual displays, and you also need to be able to read all 3 of those data displays. So at the end of this lesson, if you can definitively say those 2 things, that is our measure of success for this lesson. If any of that is still confusing to you at the end of the lesson, please bring those questions to me and your classmates so that we can work together and ensure everyone understands these 2 learning targets. One thing you might not be used to is the method that we're going to use in illustrative math. You are probably used to a math class that follows a I do, we do, you do method, in which the teacher lectures and does an example, then the class works together to do another example, and then you are given problems to try and do on your own. In illustrative math, we're going to turn that upside down. I am going to provide activities with instructions, and you are going to try and do that activity on your own for a couple of minutes. Then you're going to talk to the people that you're sitting around, and you're going to try to help each other figure out what the method is or what the concept is that we're working on that day. And then finally, at the end of the time for each activity, that's when we'll come together as a whole class and we'll synthesize everything you've learned. We'll go over any vocabulary terms. We'll go over exactly how you do the problems, how you work it out, what the formulas are. Okay, so this takes a reverse approach. It's going to start with you working independently. Then it's going to go to you working with your classmates. So I do expect this class to be more interactive. I'm going to have whiteboards on the walls. You're going to be able to go up and write on the whiteboards as an individual or a group. You're going to be able to move around, talk to people. I'm going to move around the room, monitor, see if anybody has any questions. I'm going to be able to help people as needed. And then towards the end of the time for each activity, that's when we'll come back together as a class. We'll make sure everybody understands that activity, and then we'll move on to the next one. So the first thing we're going to do every day is the warm-up. It'll usually last about 5 minutes, no more than 10. You can pull up each day's warm-up. I will also have it on the smart board, and you'll be able to get started. Again, this is going to be you read it, try to work on it on your own, then get together with the people around you and see if as a group you can come up with it. And then as a class, we will come together at the end of the time. We'll synthesize everything that we've talked about, and then we'll move on to the next activity. And this one today is a notice and wonder, and it's titled Battery Life. These are all available in Kitum. So if you want to go into the Kitum website and do it on there, you're welcome to. If you just want to do it on paper at your desk, up on the whiteboards, you can do it that way as well. So in this first one, they give us a dot plot, a histogram, and a box plot summarizing the hours of battery life for 26 cell phones constantly streaming video. And they want to know, what do you notice and what do you wonder? So you have a dot plot on top, a histogram in the middle, and a box plot on the bottom. Take about a minute or so on your own. Figure out, do you notice anything? Is there anything you're wondering? Are there any questions that come up? After about a minute or so, you can talk to other students around you, and you can go up to any of the whiteboards around the room and put these up there. Tell us anything that you noticed, and tell us any questions that this material brings up for you. What does it make you think about, question, or wonder? At the end of the 5 minutes, we'll come together. We'll go over any ideas that people have written on the boards, and then we'll move on to the next activity. Okay, our next activity is about 15 minutes long. It is called Tomato Plants, and this activity concentrates on a histogram. Again, this activity is in Kitum if you would like to do it on the website. Otherwise, you can do it at your desk on a piece of paper. You can go up on the whiteboards and use those. This one simply says, a histogram can be used to represent the distribution of numerical data. The data represent the number of days it takes for different tomato plants to produce tomatoes. Use the information to complete the frequency table. And then we have our data set down here towards the bottom. All right. Each number in this data set is the number of days it takes for different tomato plants to produce tomatoes. So when we see the number 47, that means it took 47 days for that tomato plant to produce tomatoes. You're going to use the information to complete the frequency table that's on the right side. So you can see the left column is days to produce fruit, and you have different ranges. And then the right column is the frequency. So the first thing you're going to do is work on filling out this frequency table. In the next activity, you're going to use the set of axes and the information in your table to create the histogram. So what you want is to use this data and your table that you fill out to create a histogram that looks like this one in the middle here. Once you have completed that, now on the next slide, what they're going to do is instead of having the bottom axes, the x-axis, labeled in 30, 40, 50, so this is groups of 10, the next one has them in fives. So now, how does that change? So work with your group to figure out how are we going to take that same data we used on the previous slides when we created a histogram that was numbered by tens, and instead on this slide create a histogram that is labeled in groups of 5. Okay? So for this activity, you'll have 15 minutes. Start by yourself, figuring out how to do the frequency table, build a histogram that is labeled by tens, and then do it again, but this time labeled by fives. Once you've done what you can by yourself, work with those around you and help each other. If you understand what you're doing, help explain it to someone who might not. If you don't understand what you're doing, see if those around you can help you understand what it is that you're supposed to be doing. Towards the end of the time, we'll come back together as a class and we'll do this together. And just make sure everybody understands what it is we're doing. You can take this time, pause the video right here, and try to work, and we'll come back together towards the end of the time. If you're at home and you're having to watch this on video, I'm going to go over how to do this. That way you understand, and when you come back to class, you won't be behind. Or if you just need more experience and you want to see me do this again, even though you were in class, we'll go over it now as well. So the very first thing we need to do is fill out the frequency table. And one thing you might wonder when you start looking at the frequency table is I have a group that is 40 to 50, but I also have a group that is 50 to 60. So if I had the number 50, where do I count this? Do I count it in one or the other? Do I count it twice? The way that we explain this is that the number on the low end of the range is counted, but the number on the high end of the range is not counted. So even though this does say 40 to 50, this is really 40 to 49.99999. Okay? So if I had a 50, it would not be counted here. The 50 would be counted here when it's in the low range. So the first thing I need to do is see how many times I have numbers between 40 and 50, not counting 50. and that would be the number 47. So I only have 1. Now I need to do the same thing between 50 and 60. I have 52, 53, 55, and 57. Remember, 60 is not counted when it's on the high end of the range. It's counted when it's on the low end of the range. So we're going to say between 50 and 60, we have 4 tomato plants that grew in that frequency. Next, we have 60 to 70. That would count 60, 61, 62, 63, 65s, and 68. Again, 70 does not go into this when it's on the high end of the range. It gets counted when it's on the low end of the range. So this time we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would put a 9 in our frequency table right here. Next, we're looking at the range of 70 to 80. We do count 70, but we do not count 80. We're going to count 80 when it's on the low end of the range, not the high. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So we're going to put 9 in this box. Now we count 80 to 90. We will count 80 because it's the low end of the range. We will not count 90 because we don't count it when it's the high end of the range. So that's 1, 2, 3, 4, 5, 6. And then finally, we have a range of 90 to 100. We only count this 90. Now 90 is the low end of the range. That's the only one here. So now we have our frequencies. So next, we're going to go to our first histogram where we have it labeled by tens. And we're going to use these numbers. So 40 to 50 is only going to occur once. I see the number 1 over here on the left side. So I'm going to draw a box that goes up to 1, comes over, and down. And that's my first tower. Now I look, and between 50 and 60, this occurs 4 times. So here, I'm going to go up until I hit the number 4. And that's how tall my tower is between 50 and 60. Now, between 60 and 70, my frequency was 9. And between 70 and 80, my frequency was also 9. So between 60 and 70, I'm going to draw this all the way up until the number 9. And again, between 70 and 80, there were also 9 plants that took this many days. We go back to our frequency table. In the range from 80 to 90, there were 6 plants that took that many days. So I find the number 6. And that's how tall my bar is between 80 and 90. And between 90 and 100, the frequency was only 1. So I'm going to come down here, and I'm going to draw a bar that only goes up to 1. So that is how we create a histogram. We find out how many of the numbers in our data set fall into each range, and then we draw a bar for that range that goes up to that number of frequency that we see labeled on the y-axis. Now, if we go back The last thing in this activity is to again draw a histogram, but this time, instead of my intervals being 10 apart, they're only going to be 5 apart. So we are going to use these same numbers. So I can see I'm only going to have one number between 45 to 50. So I can come on this histogram, and between 45 and 50, my bar is only as tall as 1. Between 50 and 55, not counting 55, I have 2. So this bar will go up to 2. Now I need 55 and 60. Not counting 60, but I am counting 55. So there's 2 again. Next is 60 to 65. We do count 60 because it's on the low end, but we do not count 65. It's on the high end. So this gives us 4 numbers for the next range. So this will go up to 4. Next, I'm looking at 65 to 70. We do count 65, but we do not count 70. So there are 5 occurrences. So now I'm going to draw this up to 5. Next, I'm looking between 70 and 75. I do count 70 because it's on the low end of the range, but I do not count 75 because it's on the high end of the range. So I only have 3 numbers in this range. So I want to go back down to a 3 and draw it that tall. Next is 75 to 80. We do count 75 because it's on the low end. We do not count 80 because it's on the high end. So this has 6 occurrences in this one. So I'm going to go all the way up to 6. Next, we're looking at 80 to 85. We do count 80 because it's on the low end. We do not count 85 because it's on the high end. So this one only has 3 numbers. Then I have 85 to 90. I do count 85 because it's on the low end of the range. I do not count 90 because it's on the high end. So again, this is only 3 times. And lastly, I have the number 90. That is going to go in the 90 to 95 range because it is on the low end of the range. So that one is only 1 tall. And I don't have any numbers in the range from 95 to 100. So one thing to notice, we just drew histograms using the exact same data sets, but they do not look exactly the same. Because in the first one, we had ranges of 10, and in the second one, we did ranges of 5. Now, this is where you, as the person doing these, has to understand the difference. Making my ranges smaller is going to give me more information. It's going to give me a more detailed look at what the data shape really is. The trade-off is that because I'm now making my ranges smaller, I have to draw more of them. So the smaller I make my ranges, the more information I get, the more detailed it is, but the more time consuming it is to create. When I make my ranges bigger, it doesn't take as long because in this one I only had to draw 6 bars, and on this one I had to draw 10. Okay, so histograms are going to be a trade-off. You, as the person making it, have to decide whether you want more detail or whether you want it to take less time. So that is the difference when it comes to histograms. If you still have any questions about this, make sure you ask those that you're working with, as well as ask me so that I can help clarify any questions you have. Okay, so our next activity should take about 10 minutes. Again, these activities start with you looking at the problem on your own, then working with those around you in a team effort to try and figure it out. And then finally, at the end of the 10 minutes, we'll come back together as a whole class, and I can help solidify any questions you might have, make sure you understand any vocabulary, or make sure you understand the concepts that you should have picked up, hopefully along the way working in your small groups. So this one is called Tomato Plants Box Plot. So our previous activity looked at histograms. This activity looks at box plots. Again, these are available on the Kidum website, so if you want to do it on there, that's fine. If you would rather do it at your desk on a piece of paper or up on any of the whiteboards around the classroom, that's fine as well. It says a box plot can also be used to represent the distribution of numerical data. Number 1, using the same data as the previous activity for tomato plants, find the median and add it to the table. What does the median represent for these data? Number 2, find the median of the least 15 values to split the data into the first and second quarters. This value is called the first quartile. Add this value to the table under Q1. What does this value mean in this situation? And number 3, find the value, the third quartile, that splits the data into the third and fourth quarters and add it to the table under Q3. Add the minimum and maximum values to the table. So you are going to work on your own starting off with, then get with those around you and try to complete this task. Once you have figured out the 5-number summary, use the 5-number summary in number 4 to create a box plot that represents the number of days it takes for these tomato plants to produce tomatoes. If you remember, a box plot is this one down here on the bottom. You have your thick box here in the middle, the whiskers coming off the ends. So on this activity, you are trying to use the same data set we used in the previous activity, figure out the median, the Q1, the Q3, the minimum and the maximum, and then use those 5 numbers to create your box plot. So you're going to try to figure out on your own, work with those around you. I will be around the room to answer any questions, help guide you along your journey to figure this out. And then at the end of the 10 minutes, we'll come back together and we'll make sure everybody understands. Okay? All right, so if you're watching this from home, we'll go ahead and we'll work through this. so that you understand the concepts. One thing to note on here, they have a typo. This says Q2. That should not say Q2. That should say Q3. Okay. Now, the very first thing they tell us to do is to find the median. Okay. Now, if you think about if you're out driving, the median is that strip of grass in the middle of a highway that divides the two sides. So if you think about being out on I-95, you have northbound and southbound, and in the middle, they're divided, okay? That middle divider is your median. And in math, the median does the exact same thing. It divides your number set exactly in half, okay? So what they're telling us here is this data set has 30 numbers in it. So if I were to take 30 and divide it by 2, that equals 15. That means 15 of the numbers are going to be in the bottom half, and 15 of the numbers are going to be in the top half. So I want to, first thing, order my numbers from smallest to largest. Okay, I have to put them smallest to largest before I do anything else. In this activity, they've already listed them from smallest to largest, so you don't have to worry about that. Now I need to look and I need to count. I have 10 on the top row, then 11, 12, 13, 14, 15. So my median is going to be right here. When I have an even number of data points in my set, I'm going to find the middle, and my median is going to be the average of those two middle points. So in this case, that's 70 and 72. So I'm going to add those together. That's 142. And then I'm going to take 142 and divide it by 2, and that equals 71. So my median is 71 days. That tells me exactly half the plants take less than 71 days to grow tomatoes, and half the plants take over 71 days to grow plants. Number 2 wanted us to find the median of the smallest 15 values, and that is going to be our Q1. So if we look, we are looking at the smallest 15. That's starting down here at 47 and ending at number 70. Now, if I have 15 numbers, half of that is going to be 7.5. So I need 7 of my numbers to be smaller than my median, and that's going to leave 7 of my numbers to be bigger than my median. So 1, 2, 3, 4, 5, 6, 7. That is going to be in my bottom half. That means 62 is going to be my Q1, because now I have 1, 2, 3, 4, 5, 6, 7 numbers larger than 62 in my bottom half. So my Q1 is the number that divides my smallest half in half. And then we're going to do the same thing with the larger half. The larger half starts at 72 and ends at 90. There's 15 numbers, so I want 7 smaller and 7 larger. So my 8th number is going to be my Q3. So 1, 2, 3, 4, 5, 6, 7, 8. 78 is the number that divides my larger half in half. So now I have found my median, I have found my Q1, and I have found my Q3. Number 3 tells us that we need to add the minimum and the maximum values. These are exactly what they sound like. My minimum value is the smallest value in my data set. My maximum value is the largest number in my data set. So if we look at our data set, 47 is my smallest, 90 is my largest, so 47 is my minimum, and 90 is my maximum. Now, number 4 wants us to use those 5 numbers. All right. When we say the 5-number summary, we mean the minimum, the Q1, the median, the Q3, and the maximum. That's my 5-number summary. And that is what I need to create a box plot. What I'm going to do with those 5 numbers is I'm going to make vertical lines where those fall. So we said our minimum was 47. So I am going to draw a vertical line where 47 would be. Then we said our Q1 was at 62. I'm going to draw a vertical line where 62 would be. Our median we said was 71. So I'm going to draw a vertical line where 71 would be. We said Q3 was 78. So we are going to draw a vertical line where 78 would be. And we said our maximum was 90. So we are going to draw a vertical line where 90 would be. And now I'm going to take the second, third, and fourth lines and join them. And this makes my box in the middle. I take my minimum line and I draw my whisker to connect it to the left side of the box. And then I connect my Q3 to my maximum with my right side whisker. And this has given us our box plot. Now what this does is it shows us the quarters, okay? If you think about a quarter in money, a quarter is 25 cents, okay? A quarter is 1/4 of something. So what a box plot is really good for doing is showing us the quarters. So down here, we have the lower 25%. Then I have the next 25%. Then the next 25%. And finally, the top 25%. So this middle section here tells me where the middle half of all my data is. And we're going to revisit this in a later lesson because the size of that box is going to tell us how different our data points are, okay? But for right now, you need to make sure you understand how to come up with the 5-number summary. So you have your smallest number as your minimum, your largest number is your maximum, the number right in the middle is your median. Then you look at the smallest half, and the number right in the middle is your Q1. And then you look at your larger half, and the number right in the middle is your Q3. You take those 5 numbers and you draw your vertical lines on the number line. You connect the middle 3 lines together to make your middle box, and then you draw your whiskers to connect your first line to your second and your fourth line to your fifth. If you still have any questions, please ask those around you or get my attention and ask me. Okay, so now we've reached the lesson synthesis. We talked about data representations. And the first question is, what are the strengths of each of the representations? So you can see here, they give you the answer in parentheses. Okay, a dot plot lets you see every single data point, and you can see how it's distributed. That will be important in a later lesson. But because you have to put a dot for every single data point, it's going to take me longer to draw 30 dots than it is to draw 5 lines and connect them. All right. The histogram summarizes the data into intervals that make for fewer columns. So the more columns I have, the more detail I have, but the more time consuming it is. The fewer columns I have, the less detail I have, but it's quicker to make. So you have to balance what your needs are versus what your time constraints are. And finally, the box plot displays the 5-number summary graphically. All right. You can tell the median right away. It's the middle line. You know what your smallest value is right away. It's your first line. You know what your largest value is right away. It's your last line. You know how spread out the data is because you can see how big your box is. The bigger the box is, the more spread out your points are. The smaller that box is, the closer together your points are. So all 3 visual displays have their pros and their cons. Next, what are the weaknesses of each of the representations? A dot plot has many columns of dots that can make it difficult to determine patterns graphically. Both the histogram and the box plot do not display each individual value in the data set, which means the mean cannot be calculated directly from either representation. All right, that is a key fact to remember for your end of unit test. Okay, you cannot calculate the mean from a histogram or a box plot because neither one of those shows you every single data point. And the mean is your average. So you would have to be able to add every single value together and then divide by the number of values you had to find your mean. So remember, the only one you can use to find your mean is a dot plot. You cannot find the mean from a histogram or a box plot. Next one asks, how do you find the typical value for a data set? Well, you could calculate the mean or the median, or estimate the mean or the median using a graphical representation. Okay, the mean is your average. You have to calculate that. Your median just simply means the number that is dead center of your data distribution. Okay, so for some, you would use mean, and for others, you would use median, and we'll go into that in another lesson. But if I'm asked to find the typical value of something, I'm going to look for one of those 2 values, either the mean or the median, and that's going to tell me the typical value. Okay, now is when we've reached the cooldown. Okay, this cooldown must be done through the Kitum website. Okay, so make sure you go into Kitum for this cooldown. This one is called Reasoning About Representations. You'll have about 5 minutes to go in, try and complete this on your own. This is a cooldown ticket or an exit ticket. So this is you on your own. I need to be able to understand what you do understand about what we went over and what you don't understand so that I can better address any concerns you still have. So, no working with other people on this one. Just try your best. This is going to allow me to understand what we might still need to explain more and what we understand, and we can move on to the next topic about. You can see what it looks like in Kidam right here. They give you a dot plot, a histogram, and a box plot. It is the same data represented 3 different ways. Question number 1, what information can be seen most easily in the dot plot? Question number 2, what information can be seen most easily in the histogram? And question number 3, what information can be seen most easily in the box plot? So what this really wants to know is, do you understand which visual display is best depending on what it is you're wanting to find or what information you want to get across to the person that's going to look at your display when you create one. Okay, so take about 5 minutes, just go on to Kidam and answer those. What is most easily seen with the dot plot? What is most easily seen in a histogram? And what is most easily seen in a box plot? If you're at home, go ahead, go into Kidam and answer these as well so that I have that data to understand what you know and what I might need to address when you come back to class. Okay, to wrap up, I want to make sure that we go over any definitions, any key words that you really need to understand. That way, moving forward, when they're used in lessons, you understand what it is that we are talking about. First, we have categorical data. Categorical data are data where the values are categories instead of a quantity, okay? For example, the breeds of 10 different dogs are categorical because you would give me a name, not a quantity. You would tell me a golden retriever, a poodle, a pit bull, a bulldog, okay? Those are not quantities. Another example is the colors of 100 different flowers. Even though there's 100 flowers, you would not be giving me a quantity, you would be giving me a color: red, blue, yellow, purple, orange. Okay? That is what categorical data is. Next, we have distribution. For a numerical or categorical data set, the distribution tells you how many of each value or each category there are in the data set. So the distribution tells me the spread. It tells me, are all of my data points really close together? Or are my data points really spread out? So if I asked for the ages of the people in this class, my distribution is going to be really small. Most of you are 13, 14, 15, okay? But if I asked for the height in inches of people in this class, now the distribution is going to be more widespread because some people are going to be on the shorter side, some people are going to be on the taller side, and that's going to be a wider distribution. Next, we have the 5-number summary. Remember, this is what we came up with in order to create the box plot. The 5-number summary of a data set consists of the minimum, which is my smallest amount, the 3 quartiles, meaning Q1, which is halfway of my lower half, the median, which is my halfway point of the entire data set, and my Q3, which splits my upper half into half, so my third quarter versus my fourth quarter. And then it gives me the maximum, which is my largest value. It is often indicated by a box plot like the one shown, where the minimum is 2, the 3 quartiles are 4, 4.5, and 6.5, and the maximum is 9. So one thing to notice, if I'm looking at this box plot, this line is my min, this line is my Q1, the middle line is my median, this line is my Q3, and then my last one is my maximum. So when you get to your test and they give you a box plot and they're asking you to either find one of these or compare one of these, make sure you understand this is what it visually represents. Then we have non-statistical questions. All right, non-statistical question is a question which can be answered by a specific measurement or procedure where no variability is anticipated. For example, how high is that building? Well, the building's not going to change height, okay? If I measure it today and I find out it's 100 feet tall and I come back in a week and I measure it, it's still going to be 100 feet tall, okay? Or if I run at 2 meters per second, how long will it take me to run 100 meters? Well, if I keep the same pace the entire time, I can simply take the total distance, 100 meters, divide that by 2 meters per second, and it will tell me that it's going to take 50 seconds to run that distance. Because I'm not speeding up or slowing down, it's not different people running at different speeds, there's no variability. And that is what makes something a non-statistical question. It has a specific answer with no variation. We have numerical data. Okay, earlier we talked about categorical data. Now we talk about numerical data, and it's exactly what it sounds like. Numerical data, also called measurement or quantitative data, are data where the values are numbers, measurements, or quantities. For example, the weight of 10 different dogs are numerical, because if I asked you, how much does your dog weigh, you're going to give me a number answer, and that number is measuring something. It's giving me a quantity. So it could be 6 pounds or 72 pounds or 18 pounds. But the answer you give me is going to be a measurement of something. It's going to be a quantity of something. That makes it numerical data as opposed to categorical data. And lastly, we have statistical questions. A statistical question is a question that can only be answered by using data and where we expect the data to have variability. Earlier, we talked about non-statistical questions, which is something where the answer has a set value, there's no variability in it. Now we're talking about statistical questions, and these have answers with variability to them. So, who is the most popular musical artist at your school? There's going to be a lot of different answers. That's a statistical question. When do students in your class typically eat dinner? If I ask that question, I'm probably going to get a lot of different answers from you. And which classroom in the school has the most books? Okay, well, that's probably going to change depending on what school you go to. Maybe it's the math room in this school, but if I went to Central, it might be the English room. Okay, so these are questions where the answers are going to be different, and that variability is what makes something a statistical question. So that ends the PowerPoint and lecture portion of today. Now, there are practice problems on the Kidum website for each lesson that we go through. So when we have extra time, use this extra time to look at those practice problems and see if you understand them. Okay, those practice problems are a good way for you to say, yep, I know exactly what to do here. I don't have any questions about it. I'm ready to do a test with a question like that. Or if you look at those practice problems and you say, I don't know what I'm supposed to do here, I don't know how to get started, or I know how to get started, but there's a part where I'm getting hung up, those practice problems will help you understand the questions that you need to ask each other or ask me. And you can do that in class, or like I said, if you go to the class website, there is a forum page on there. And there is a forum page for each unit we're going to go over, as well as a forum page for questions about the class in general, questions about the school in general, as most of you are freshmen. So make sure you go on and use that forum to ask questions. You can answer each other's questions if you know the answer. I will monitor that forum as well and answer any questions that go in there. So anytime we have left in class, you can use to look at these practice problems, and that will help you understand what questions you need to ask. So if you were here in class, thank you for your participation. If you had to stay home today for any reason, hopefully you came on here, watched the video, and you understand the material we went over today so that when you come back, you're up to speed. And if you needed to go back and rewatch this after class, bring in any questions that you might have. That's what I'm here for. I'm here to take those and make sure we clear up any questions, misconceptions, or doubts you might have. That way we have you ready to go when it comes to the mid-unit and end of unit, as well as your midterm and your final. And that way you can have the best quality foundation of algebra so that as you go forward into Algebra 2 and geometry and your SAT, you can have the best possible chance for success. Okay? So I'll see you tomorrow, and thank you for your time.